All right, so one of the ways that we can make integration by parts a little less tedious and difficult is by using what's called the tabular method. Now, at first, just like integration by parts, it's going to seem a little weird and awkward, and you're just going to want to stay away from it, but trust me, it's a really, really huge time saver if you can learn it, okay? So, just to recap, we use integration by parts when we have two functions multiplied by another, or in the case of, in special cases, we have one function and we give ourselves the second function. But we'll talk about that in another video. But in general, we have two functions and they're being multiplied by one another and we want to break them apart, right? So how does the tabular method sort of do this for us? It's very, very simple. There are three columns. First column is the sign column. Second column is the differentiation column. Third column is the integration column. They have to be in that order, okay? So again, sign, differentiate, integrate. It's very, very analogous to the traditional method of doing integration by parts, but it's just a little neater and makes it a little harder to make mistakes. So how do you actually read it? It looks very simple, so how do you actually do it? You don't read straight across when you're reading off your terms. You read across and down. Okay, so let's, just for an example, go ahead and do this with placeholder functions f and g, okay, and then we'll do a real example. So this integral is going to be equal to, I'm going to go across and down, so across and down. So plus times f of x times integral of g of x. So f of x times, and then I'm going to write g1, because I don't want to write the integral symbol here and make it all nasty looking. So then I go to my next term, next row. So starts with minus f prime of x and the integral of g of x. So go across and down. Minus f prime and g2 I'll call it. Okay. Then next one is plus f double prime and the third integral. So plus f double prime and g3. Okay? So hopefully at this point you'll have reached 0, okay? Because remember, the way you're going to choose your function to differentiate is you're going to choose the function that's going to go to 0 the quickest, okay? So if f of x was a polynomial, if I had a polynomial and a sine function or a polynomial and an exponential, I'd use the polynomial to differentiate because I'm differentiating and it's quickly going to go to 0, and when it's 0, I'm done, okay? So hopefully by this point, your this term is going to be 0, and you don't have to do another row. But there are certain cases where neither of your functions are going to reach 0. You can still use a tabular method, except the very last part. If you're going to stop after 4 terms, and you just want to cut it off here, and you can't go down anymore. You don't want to go down anymore. You can just read across, straight across, and put it in an integral. So I'm going to read straight across and write minus f third derivative of f times the third integral of g. But I'm going to put this whole thing in an integral. Okay? So that's a little abstract. Let's take an actual example and actually do this to see how it works out. We got x squared sine x, and we're going from 0 to pi. Perfect candidate for integration by parts because we have a sine function, a trig function, and a polynomial. So the first choice we got to make is which one are we going to differentiate and which one are we going to integrate. I'm going to differentiate the x squared because it's going to go to 0 very quickly. If I differentiated sine x, it's just going to keep alternating sine x, cosine x, sine x, cosine x, and I'm never going to get anywhere. The whole point of this is to make one of these columns, this one, go to 0 so that you're going to be done. And you don't have to do this remainder term. Okay? So, all right, I'm going to draw my table, sine, plus, minus, plus. Then I'm going to write my differentiate. Remember, it goes plus sine chart, differentiate, integrate. So sine chart, differentiate. I'm going to start with x squared. Differentiate it once, 2x. Differentiate it twice, 2. Differentiate it 3 times, 0. And we don't even need this last row. Okay? Third column, we're going to integrate sine x. write integral of sine x minus cosine x, integral of minus cosine x minus sine x, integral of minus sine x cosine x. Now it's time to read off the table. Remember, we go across and down. So our first term is going to be, our sign is going to be minus because it's minus times plus plus. So it's minus x squared cosine x. Second term, again, we're going to go across and down. Minus times minus is plus 2x times sine x. Third term, across and down, 2 times cosine x. And that sign is plus, 2 times cosine x. And this is all evaluated from 0 to pi. Okay? We're almost there. So now let's evaluate it. So we're evaluating it at 0 and pi. Now you can just do it, you can just go ahead and do it, but if you're a little patient and you look at these terms, you can notice that at 0 and pi, at both places, sine x will give you 0. Right? Sine is always 0 at 0 and pi. So he makes no contribution to this integral. So now we're left with these two terms at pi and 0. At pi, it's going to be minus pi squared cosine of pi, which is minus 1. So it's just going to be pi squared. Then 2 times cosine of pi, which is minus 2. Now let's plug in 0. The 0 here will give us a 0 because of the x squared. And then plus a 2 times cosine of 0, which is 1, so 2. So together, when we add them up, we get a pi squared minus 4. And that's our answer. Okay, so as you can see, it's very simple. If you were to do this traditionally with the traditional method of integration by parts, it would take you a while. So this method, the tabular method, is a huge time saver if you can master it and do it quickly, and it's very easy to master. So there you have it.